All right, everybody, thank you for joining us today. For this presentation, we have mixed reality and online education as an immersive learning opportunity by Christian Janke, assistant professor of the practice for the Worldwide College of Aviation, and Dr. Stefan Kleinke, associate professor of the practice for the Worldwide College of Aviation. Take it away.
Thank you very much, and thanks everyone for joining us today. We will talk about our ideas of virtual reality and 3D technologies in online courses, and I will hand over for a general introduction of the topic from a pedagogical perspective to my colleague, Dr. Kleinke. You have it.
Yes, first off, yes, it is associate professor of the practice as of today for Chris, so congratulations to that.
Thanks, yeah.
And starting with that, a little bit of the background. So we're obviously in an asynchronous learning environment, and the big question is always how do we fit the activities and learning or course designs and activity designs into the bigger picture of the different learning theories that should support our learning in those environments. So a couple I put on here: social learning. How do we facilitate the students working with each other? Emotional engagement, experiential learning. How do we get them to experiment with stuff hands-on? How do we get them cognitive at that level where we want them to be? And how do we foster adult learning, basically? Next slide. A couple of issues that research identified in fully asynchronous online learning environments are disconnectedness for the participant or isolation, so they may not feel fully involved in their education. There's a possibility that there's a lack of experimentation and hands-on manipulation, just based on that everything is set up obviously in the online environment, so it's much harder for the students to or for us to replicate what students usually would experience in lab and environments on campus. There may be a lack of multimedia, multimodal, or multi-domain engagement. So a lot of content may just be presented in one format, like reading, and then coming back to do discussions. And then lack of relevancy and applicability, I already covered yesterday a little bit in our panel discussion, is another issue that may arise in asynchronous online learning environments. So the big question for us was, how do we address this problem? Next slide. And our proposed solution here is tapping into the abilities, the technological availability of simulation and virtualization, and how it has advanced in the last in the last 2 decades, basically, to the point where it makes sense to take a look at how we can implement these into our learning environments to do all the things that are basically on the slide here, and enhance student engagement through interactivity, give them opportunities for self-regulated exploration and experimentation, provide immersive environments for virtual collaboration, and then allow task-oriented problem and scenario-based approaches to learning. We can also use virtual reality or simulation to support the content, so to present it in another way than just reading about it. We can support the processes through this, and obviously we can adapt it to individual student needs. Next slide. Nevertheless, when we use virtualization and simulation, we have to keep in mind there is obviously limitations. One area that we have to look into is what's the fidelity of what's out there. And there's 2 main concepts here: absolute and relative perceptivity. One basically addresses how well the participant or the user of the virtualization simulation feels about what is presented to him. And then relative perceptivity more or less measures or tries to assess how well the behavioral response is the same as in the real world while the user is using virtualizations and simulations. And that gives us an idea about how useful and how usable it is for the different learning activities that we want to use it in. Yeah, that's kind of what we're doing here. Next slide. So in conclusion, for my part of the intro here, when we try to assess where we want to evaluate or how we want to incorporate virtualization and VR virtual reality or mixed reality into our online environments, then we need to look at what's the task technology fit? Where does it fit into which learning activities? How do we support it logistically? How do we support it technically? And what technology we use for which task? And that's kind of where I want to hand it over back to Chris.
Great, thank you very much. So after our bit onboarding here, I wanted to give some small background about virtual reality. And it's not only virtual reality, but also 3D technologies, because it can apply to virtual immersive environments, but also to created videos in 360-degree video. And you can review them in VR headsets. I will introduce them in detail, watching pre-recorded videos, and also be a part of a virtual world that can be created by an instructor. But let's look at these 360-degree videos. This is something that if you do not have a VR headset or experimenting with it, it's not very well known. There is a concept that is YouTube VR, and people create videos there that they use, that they just somehow upload it in order to show what they have been doing. But for people to be part of that in a very immersive way, you need a specific 360-degree camera for that. And they are also on the same platform, educational videos already. On the right side, you can see that inside the human body. So that is something that has been created, but you can also review or create your own videos. And you would review the video as you would be standing next to the person, something like a Google Street View in video, so to say. So what is the technology currently on hand? We have here a comparison of headsets, and I found it very funny that this was a buy it, but there is no price given here. But the only one is the Meta Quest Pro, which is 1,000, but all of them are below 1,000. Some of them are even below $500 euro. And they are really now without any kind of attached computer. They can completely work as its own little computer with two little displays that display for the eyes, and then you can really use them and potentially walk around. You shouldn't do that, but it is possible to move along. And so this is the current technology that is there. It's available. They are all released, and the Oculus Go is around 320 US dollars, from what I have been seeing. So really affordable. So having that as a background, how can we actually start using VR headset as course material in online courses? And if we do that, how do students receive the VR headsets? And how can we then, before that, produce learning material, active and passive, for activities for course integration? In general, for example, here in the Bachelor of Science in Uncrewed Aircraft Systems, we have a longer history of using hardware as course material. So instead of a textbook, students buy a little computer, a logging USB stick, or a little drone, and that works very well. And students really appreciate the opportunity to have hands-on experiments. So the tradition is already there. We also use simulation, everything from flight simulators, construction, computer-aided design, so that we have a longer experience with the logistical aspects of using simulation with student subscriptions as course material as well. So what we did in the past, Stefan and I, we applied for preliminary funding. So we bought some headsets, tried them out, also the 360-degree cameras, and we're trying to find out how exactly they can work, did some sandboxing. And it was very interesting to see that it's not only the hardware, but also the software. And the software is probably, next to the logistical aspects, one of the major things that need to be reviewed when it comes to accessing the course material, because we do not have a Canvas access right now to a metaverse. Maybe in the future, but it needs to be something that is really accessible for every student that would potentially have a VR headset to get into those learning materials. And that is something that needs to be considered. The learning materials in the courses, of course, need to be prepared and created. And that is something that needs to be done in collaboration with IDD, and also the videos by potential instructors, full-time faculty or adjunct faculty, course developers. So there is a longer process involved for that. And The logistics are really when it comes into play, how students would actually receive these headsets. So there must be an implementation strategy and recommendation for VR technology. And one opportunity, this is just an idea because some of these headsets are price prohibitive as course material, but it would be possible to develop a loan model that one central entity, like a bookstore, for example, is renting them out to the students and shipping them, logging everything after receiving them back, cleaning, and then sending out to the next students for a very small fraction of the cost for the purchasing. And this can bring down the students' cost and increase availability and affordability. In general, it would be possible if we have these headsets that are used as course material to brand them with the Embry-Riddle worldwide corporate identity. I will show you a picture at the end of the presentation, how this could look like. But now let's look into the VR goggles. What are some examples that is already being done by using the particular learning environments? So this is Unity. Unity is one of several online virtual environments where you can create your own worlds. And this here you can see is for maintenance. Here's an example for welding. So there are some examples where you can really start without any kind of other hardware involved, doing some of these activities and thereby learning how to extinguish a fire, how to build a brick wall. You can do all of that also in the beginning in virtual reality. We do also use several sensors in the courses to create virtual environments by capturing data on the real world with LiDAR on tablets or cameras, and that can be reviewed in VR as well. And a large part of our courses about drones are covering the manufacturing and engineering of drones, and there we use computer-aided design from very small systems with TinkerCAD up to Fusion and SolidWorks, where drones can be built, and those can also be reviewed in virtual reality. That is possible. So here, this is a more smaller version of a very beginner drone that has been created by a student, and this works in general very well. Here's an example I wanted to give regarding a particular project that is currently going on with the Grönstedt Group. Grönstedt is a platform and company that is working with education and virtual reality. So they're currently already working with the United States Navy, offering services also while the sailors are in the submarine underwater deployed, because all of that is container system, doesn't need to be fully online. That is general working. And I found in the paper of the Grönstedt Group a very interesting visualization why we want to be in the green sector, because we have a high realism and it's portable and also affordable, whereas you have a high realism and it's something that is really you wanted to have for one high level turbine maintenance. You can use a much better VR goggle and a standard for that, but we are really immersive with that. We are also very much affordable, and this is something that an area that should be explored for online teaching. So the requirements in general are, some of them have been mentioned before, the availability for all students, ordering and receiving shipping. Also, it must be a little bit in the level of a textbook equivalent, and the learning activities and assignments need to be applicable to the course learning outcomes. We need to have measurable and gradable results as well. So it's also possible to get into the system as the instructor and see what the students are doing. They can upload what they have been doing. And in general, for many of the participants and students, it is very new. So we must have onboardings and tutorials available. And then the classroom aspect comes in. That is also something that we can see when we have the peer review. That is very important. So the lessons learned here, VR kits in general have a very engaging immersive learning environment. It can be applied to many degree programs. Students can materialize, explore, trial, and improve. And in general, it is a constructivist immersive learning, and it's an excellent plagiarism prevention. Not only plagiarism, but also a generative AI. So if you are working in that, it's something that will not be possible. Here, this is the only thing that is created with AI in this presentation. I asked ChatGPT to create a potential VR headset, how it could look like. And just imagine our students using these headsets and talking to other potential students and prospects and persons about what they are doing. So I think it would be a great opportunity to have a course material like this. And I hope I'm ending on time with my presentation, and I'm open for questions. Thank you very much.
Yeah, that was perfect. This is super cool, especially from a student point. You know, I personally learn better by doing, and that's one of the best ways to learn is to actually do it. And this would be so cool to get executed in for worldwide courses. But we do have a question here. Have you used VR experiences in your class? And if so, how were you able to measure the effectiveness of the learning interaction?
Not yet. At least I will give over to Stefan as well. So I was not able to do that because just because of the logistics. I was not able to provide a classroom set of VR headsets to students in the online environment. I've used it for other educational purposes, for training how to fly drones, for example, with an audience here in Germany, different age groups. Also, I based on my non-empiric subjective impression, have been seeing that students, because of the engagement and the great learning curve, really liked it, and there was a very good achievement of learning outcomes. How about you, Stefan?
Yeah, similarly, as we already said, like implementing it here at EIU is obviously still at the forefront of why we are like trying to address this, because if we could get it into a student classroom, then we can start taking data and expanding the project basically. So
Yes.
All right, and we have another question as well. Are there grants available through any of our corporate partnerships?
I'm not aware of any. I'm not. I don't know. Stefan?
not that I'm aware of right now out of the top of my head. So
Yeah. It's an opportunity. We wanted to just really show what is possible and how it could work. Because based on our assessment, these platforms, these headsets are definitely applicable and usable in online courses if the logistics are right. So the two major milestones to achieve would be how students get the headsets. And I think the loan model provided by a central entity would be a great opportunity. And second, there would probably be a larger effort on the activity and course design aspect to do that. But again, there are these little cameras where you can make videos, you can work with, and we have been doing extensive and very, very good work in this field for VR environments. So, Dr. Brian Sanders, for example, is an expert in this field when it comes to Unity environment, and he's also been doing experiments with that as well.
All right, and I think we have time for one more question. How much does it cost students to purchase entry-level drone equipment?
Okay, entry-level drone equipment. So the smallest drone in the classroom that we are using, I'm teaching this class right now on the 318 robotic systems. It's around $120, including shipping. That's a small indoor drone that has the size of the palm of a hand, and can be used for indoor learning of drone flying. Also block-based coding, understanding computer science with regards to algorithms, letting the drone move into free space. If we have other courses that go outside, I will hand over to Stefan to talk a little bit about the gear for that.
yeah, similarly here, I'm teaching on the 318 right now too, in parallel with Chris. So yes, the little ones around $100. As we get to Department of Flight Equipment, we are looking more in the drone range of 400 to 600. Some students willing to purchase up to 1,000 or slightly above. And then once we get above those levels, we get into the prosumer range where the students are already dedicated to a professional activity that they want to continue with the drone afterwards. So they already have a projection of what they want to do and how they want to do it. And so they are willing to invest obviously more.
Yeah, and I believe that is all the time we have for that. Thank you, Christian and Dr. Kleinke, so much for that presentation. Very interesting, super excited. Hope to see that end up working out. And thank you so much to those of you who are in attendance. I know actually Dr. Brian Sanders is doing a presentation later today as well. So if you enjoyed this one, you might enjoy his. But yes, thank you so much, and I hope to see you in one of our other sessions.